Hello, ladies and gentlemen. My name is Strom. I wanted to make a video today talking about some redstone contraptions for timings. As you can see behind me here, we have some things in Minecraft. Everything takes time. And so I'm going to talk a little bit about timings in redstone. And then we're also going to move on to the signal limiters, which are there behind me, which are going to limit the number of input signals that you can get. But we'll get to that later. First, I want to go over some basics, and then we'll get into those systems. So let's get into it. Okay, so here we have some different systems in Minecraft that take time. There are a lot of things that just take time. For example, here, creeper falling, 22 blocks, takes about 1.5 seconds. Lava flowing to its full extent, 4.5 seconds. Water flowing to its full extent, 2 seconds. Smelting an item in a furnace, 10 seconds. Here we have a cobblestone generator, about 1.5 seconds each. In between each flow of the lava into the water. Here we have a chest filling into another chest with a hopper. Actually takes a number of minutes there, as we can see. Here a hopper minecart filling up. Still takes 20 seconds. Even though it's fast, it still takes about 20 seconds to fill all the way. And then, of course, last but not least, the thing that we all want to know the time of, TNT. 4 seconds. So 4 seconds from the time you light the TNT to the time that it explodes. So that's what these systems are over here. These are signal input limiters. And what it's doing is no matter how many times you send a signal in through it, it's only going to let a signal come out of it every X number of seconds. And I have a few different systems here where you can control those number of seconds. But basically, even if we're spamming this with signals over and over again, this is only going to activate whenever we want it to. But then it'll reactivate as soon as we want it to, okay? So that's going to be useful for something where you want it to send a redstone signal as soon as it's ready to go again, go off. And we're going to get into this system over here that's dropping TNT. We're using that to limit how often it's going to drop TNT so we don't have a situation like this. Okay, first I just want to start out talking about a few of the basic redstone things that we're going to be discussing here. So as you all know, when you hit a button, it releases a redstone signal for X number of seconds. Stone buttons are shorter than wood buttons, etc. What this system is doing here, this is called a pulse extender. And what this is doing is there are 3 different lengths here. So there's 1, there's 2, and there's 3. So these are going to be different lengths of pulse extensions. What it's going to do is it's going to take this button and it's going to lengthen the amount of time that that signal will go into these different objects. So when I hit this button, we're going to see each of these systems stay active longer. They all activate at nearly the same time, as we saw by the dispensers firing out the arrows. But those pistons will retract at different rates. The problem with just using this is if we send another signal into it, as you can see, everything stays active, those pistons stay active, but the dispensers aren't going to do anything. Over here on the blue circuits, we have a few different types of clocks. These are fast clocks. So here is a repeater clock. You have a repeater that's going into your redstone torch. That redstone torch then sends a signal to another repeater, which loops back to turn off that redstone torch, and it goes in this circle. And I have it turned off right now by this lever, but we'll see that in a second here. So we can see this is a decently fast clock, but we can speed this up even more by taking the ticks out of it. So it's going to run every second there. You can have 0.4 seconds to 1.6 seconds, depending on what kind of delay you put on these. Okay, as we can see there. Over here we have an observer clock. What this is 2 observers that will face into each other and causing them to constantly change state and constantly send a signal out. So if I turn this lever on and push this in front, we can see the back end of the observer is lighting up there, and then it's sending out the signal really fast. Okay. This also, as you can see, that block is bouncing up and down, will give what's called a 1 tick pulse, which means that a sticky piston will release its block. So we can see there that's going fast, but that's still kind of going up and down at a slower rate than the dispenser is firing. Here is another example of a fast clock. This is called a comparator clock. This comparator clock is feeding a signal in the back using this lever and then it loops back into itself, and you can see this spot right here is lit up. It's called subtract mode. So when we do that, it's going to be able to pulse back and forth. But as you'll see, this signal is so fast, this piston is not getting any repeating signals. The dispenser is. The dispenser is still throwing out arrows. But this piston is actually just staying extended, because by the time the signal disappears and it wants to retract, there's another signal coming into it. So these are two very fast clocks with different applications here. This is another type of redstone clock. This is called the Etho Hopper clock. This is designed by a player called Etho quite a while back. It's quite a popular hopper clock. The nice thing about this is it can get to under 1 second, but it can go up to 250 seconds, the number of times it pulses out. Okay, and the way it's doing that is dependent on how many items you have in the hopper. Okay? What it's going to do is it's going to send items to the other hopper once you activate it, and it's going to take a certain amount of time for it to come back to the other side. So here we have 32 items, but if we were to reduce this down to just one item, that would go every 0.8 seconds. Okay. And then let's just keep that back at 32. So this can be used for really slowing down things. And we'll see, turn this lever to turn it off. You can see that's going to stay activated for that stack of 32 items. And then on that stack of 32 items way back, this is going to deactivate. And this is not going to fire, because now it's just a disappearing signal, because that redstone block is giving this power. But we'll see when this shifts back over, this is going to shoot another arrow. This is going to retract. We will get to this system in just a second. This is what we're going to be using, but I just wanted to touch briefly on these purple lines. These are not necessarily a piece that is going to be used in these systems, but it's something good to know about these mechanics. So when you send a signal through a block, a repeater can then pick up that signal on the other side. However, if that block then also powers a sticky piston, so that that sticky piston is extended, let me just show you here and leave that extended, you can no longer send a signal through the piston head. See how this block just has a piston head in it? You can't send a signal through there. So what that's going to do is it's going to shoot up, give out a very quick signal. It's what we call a one-tick pulse, kind of like an observer. But basically you're turning a button into a lever type action, because this sticky piston is going to fire out this block, but it's not going to retract it because it's only going to be a one-tick pulse. Next time you send a signal through, this piston is going to reach out, grab the block, and pull it back. I'll show you here real quick. We hit that button. We can see that block, that redstone block, is now extended over to these things. Once you hit that button again, it's going to pull it back. But you can see how very quick that signal is going through and extending that piston. So every other time we hit the button, we're getting that dispenser firing. Okay. This is something very similar, but this is more related to what we're doing in the reducer. So now that we've actually put a delay on this repeater right here, see this one has no delay, it does one tick. This one puts a little delay, so it is actually a 2-tick. Now we're going to see it's actually going to push this out real quick and pull it back. This piston though is only going to get a 1-tick pulse. So now we have the opposite. We have that one going up and down each time, but we have the dispenser each time we're pressing the button. Okay, that's another system we can use right there. This is the system that we're going to be using for the signal input limiter. Okay, what we have here is we have the same signal going through 2 repeaters. Okay, so we're using one to extend the piston out and one to go through the block. Okay, so what we're doing is we are then sending that signal through the block, but it's also getting extended at the same time, turning this block into a piston head, which means it stops sending the signal. And as we can see here, we're just getting a short signal coming through here. Now this is a kind of a riff on there. This would also work as a T flip-flop, as we can see there. Now, we've reviewed a lot of the components that are involved in this, and so I'm actually just going to kind of go over how these systems work. And I have a few different systems here. These are all based on the same concept, but they're just using different timings, so different lengths of time. Okay, so let's review these and go over them now. Now, this is the separate circuits that are used inside these different systems. And we are going to review these right now just so you can kind of get an idea of what each of these modules do and break them down, okay? So in all of these systems, the pink, yellow, blue, and red systems are all going to stay the same, but the green system is going to change. So I'm just going to review these on this first one real quick, and then we'll get into the actual green system. So the pink concrete is just our input signal, okay? This could be the button, a clock, a lever, whatever you want to do. This is just the signal that you want to send into the system. The red concrete is what's actually going to allow the signal through or be extended to not allow the signal to come through. The the yellow signal is going to be just the stabilizer, what's going in between the input and the output, okay, to make sure that it doesn't loop back on itself with power. Blue is just going to be output signal, so going to wherever you want to power it. Doesn't need to be this long, and just brought it to the front for everyone to see while they're messing with the levers and the clocks. Okay, and then the green. The green is our actual extender that's going to keep this piston extended, allowing us to only send a certain number of signals through. Now we have to have the green input, the green circuit connected during this yellow stabilizer, okay? If we send it in at the beginning, every time we send a signal in, we're going to reset that repeated signal, and this will just never turn off. Now we'll talk about what this green circuit is actually doing. So this green circuit is what's extending that signal for a length of time to keep this piston extended out. So here we're using that comparator pulse extender that we were talking about right over here in that other green circuit. What it's doing is it's taking in a signal in the back. It's then sending the same signal out the front, but it reduces by 1 as it moves over each block. So here, if we sent in 15 here, we'd have 15 here, but then 14 here. This comparator would now have 14 coming in and would send out 14, okay? But then as it moves over, so it's 14, then it drops to 13. 13 in, 13 out, down to 12. 12 in, 12 out, 11, 11, 10, 10, and it goes around, and that signal will slowly decay until it gets all the way down to 0, and then it will stop. So what we see is when we hit this button, this signal is going to slowly decay until it goes down to nothing. And you see that? You see how that's working there? That's because it's looping back and forth and reducing slightly each time it goes in. So this is the same style of green circuit over here, but what we've done is we've extended out those comparators. So now we have 2 on each side, thereby making it take longer for the signal to decay as it goes around the loop. You also notice I've started to add in here some more signal stabilizers, because what's going to happen is that loop is going to take a little bit longer to run now that it's longer. And so if we're just sending a pulsing signal over and over again, it's not going to fire the piston and keep it extended. I'll show you here. This is with it set up with the stabilizer. You hit this button, it's going to take longer for this signal to decay. The decay is slower, and that signal is what's keeping the piston extended. If I was to take out this stabilizer, we have a double fire in the piston there and a double fire in the retract, because this is kind of decaying slowly and having it come back in on itself. Over here we have the 4-second timer. Again, same concept, just extended. So we have 3 comparators on each side. Going to take even longer for that signal to decay. Same concept over here, surprise, surprise. This is the 5.2 second, except we've now extended it to 4 on each side. But you'll notice here we started to add in even more signal stabilizer, because it's going to take a while for it to move around this loop, and this piston is just going to go back and forth, back and forth. And if you send a signal when this piston is not extended, it's just going to send another signal through the system. So here we have the extended one. There we go. And it's just taking longer and longer to decay. And as long as that red concrete block is extended, we can't send more signals through there. Okay. Notice as soon as it retracted though, since we're using a button that has a longer signal, it did allow it to send through there. So that's what those specific timers are all about. Even if you hit the button too early, it's going to limit it. There we go. This final version is the one where it is super configurable, and this may be the best one for all scenarios. It depends on really what you want to do with those signals. But this is the etho hopper clock version. Okay, so here in the green circuit, we have an etho hopper clock. Except instead of like over here, where it's just one dot on each side of the etho hopper clock, we have this also hooked up to a torch. Okay, so not until that torch turns off is it going to allow it to retract the piston and continue the timer back and forth. So that torch is acting like our lever. So what this will do is it'll empty everything out of this hopper into this hopper. Once this hopper is empty, it will allow this one to start emptying and send it back. But notice how everything is just sitting there right now because this signal right here. So basically that's what we're doing. We're using that signal to turn on the next cycle of that hopper clock. What this is going to do is as long as there are items in this hopper, at least one item in this hopper, this is going to stay extended here. Okay? This is going to keep this system active by extending this piston using that. Okay? So we hit this button. You can see this is pushing out that piston. You notice the system is running here. And even when we get to 32, it's not going to cut it back. It's going to start sending the items back to the other side. But not until this hopper is completely empty is this piston going to retract and allow us through. Now, this system, its configuration is you can have it go, like I said, from 0.8 seconds to 256 seconds because those items in there. Each item that you put in there, okay, so if we did it to 16, we're going to reduce it by half, 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 half. Each item you put in there is going to be 0.8 seconds. Now, on this etho hopper clock, you're probably not going to be able to get down to 0.8 seconds. Notice that we have that double push in there. Okay, so this is really going to be for a more extended system, but we can just use just a few items in there. And let's just put, okay, we'll have 4 in there. This is going to show us that pulse input limiter. Okay, and that is still working. Or we can put in a whole bunch of items into this system. And let's just take this out. There we go, all the way up to that 256 seconds or anything in between there. This is going to take forever to allow another signal to come back in. But there are a lot of applications that could be used for this, and I'm really interested to see what kind of ideas people come up with. So if you have an idea for what this signal input limiter could be used for, please put it down in the chat. So this over here is another fungus tree farm. What this is going to do is it's going to drop down 4 pieces of TNT at this wall of nether tree bits that's coming at it, blow up those nether tree bits, send it down in that hopper right there. Problem is these trees go actually really fast. So when we're hitting it with this clock right in here, with this dispenser clock, it's going to be constantly throwing bone meal in that. It's going to grow trees very fast. So if we were to throw down 4 pieces of TNT every time we grew a tree, we would just blow up the entire system. We'd start blowing up over here, we'd blow up this corner over here, we'd blow up these dupers, and then more TNT would drop down and then blow up over here until eventually the player's dead and the farm's gone. We are using a signal input limiter to keep this piston extended so we can only take in a signal every so often so that the TNT is only allowed to drop before it's going to hit that blast radius of the previous TNT, so it's not going to go flying. Okay? And I'll show you this system right here. We'll throw in the warped fungus. Boom. So see, we're going to have some TNT fall. But no matter how fast the other trees fall, it's not going to drop a new piece of TNT until that signal limiter allows a new signal to come in. We're only getting a certain amount there. So even if I just stay here and keep this button held down, constantly planting trees, you're going to hear in that left ear how many times the TNT is actually dropping down. Okay? Because I'll show you what's going to happen if you don't have that signal limiter. Well, let's take this signal limiter out of it, and every time we grow a tree, we'll just send a signal to it. This is going to be... Why am I doing this? Why am I doing this? Okay, so every time we grow a tree, it's going to send TNT through, and let's see what happens. Yep, that's too much TNT. Yeah, see, it's leaking out the sides now. We blew away some redstone, but if we just would have had an input signal limiter here. Should have used a pulse limiter. All right, everybody, thanks so much for watching. I hope you're able to learn something today. If these signal input limiters are not really your speed, hopefully you were able to get something from over here with the clocks and the hopper clock, the T flip-flops, the pulse extenders. Hopefully that's able to get you something going in Minecraft. If you have any comments on this, or you come up with new ideas for how you can use these things, please put it down in the comments. I would love to see those things and check those out, what you've got these applied to, and I will see you later. Thanks for watching. Bye.